All right. So this is actually new to the year 11 course. This used to be in the year 12 course, and now they've introduced it in the year 11 course, which will make it easier for you next year. So I'm going to introduce this to you. This is called the normal distribution, otherwise known as the bell curve. Has anyone seen this before in any context? Tara, where have you seen the normal distribution slash bell curve? Psychology. Yes, psychology is probably the main example where it appears. Um, what aspects of psychology though? That's okay. So I would imagine a lot of you are doing psychology. Yeah. All right. So psychology. Where else have people heard of the bell curve or the normal distribution? Can you expand on that, Bruce, if possible? What do you mean by therapy? You've just thrown a word out. Can you give an example? So, I think it's mood. Okay. So, I'm happy to include therapy, but let's include it under psychology, just to make things simple. Huh? Mental? Mental therapy. So, what do you mean by that, Ash? Well, not sure. Um, Potentially. Okay, so you don't need your laptops open, so shut them, please. That's that's you, Jai. You don't need your laptop open, so you can close it. Yes, if you can organize the remote, Emily. Yeah, that'd be great. Yeah. Well, I can't do it right now because I'm writing. That's the bell curve. Okay, I should have drawn this first. So psychology is a great example. Any other instances where we might have seen this? ATAR scores. Oh, in life skills with this match, I heard swear I heard about that in life skills. What did you hear in life skills? He was like showing like the gap, like I don't know how to explain it, but I swear someone came in our life skills class and was just randomly explaining about how ATAR skills work. Okay. And I don't even remember that. All right. So So it's not the ATAR that's normally distributed, it's the VC study scores. Okay? It's also in your assignment. I snuck in a question about that, if you read far enough. Tyler, can you sit down? Yeah. Okay. I'm just going to write nature. So almost anything that you can measure, such as height or weight, for any animal or human being, usually you're going to get this characteristic bell-shaped curve where most of the measurements are in the middle, and then as you get further and further away from the average, it's less common. So I reckon if I measured everyone's height at this school, I would get a graph that looks like this. If I measured how long your arm or your hand span was, you probably get a graph like this. If I measured your weight, now we're a bit sensitive about our weight sometimes, but you also get a graph that looks like this. Depending on where you go after school, you may see you will probably see the normal distribution again. You'll probably hear it quoted. All right, so a normal distribution is described. Sorry, there's no cursor now, so it's harder to write. Is described using two statistics: the mean and the standard deviation. All right, so the mean I'm going to write as x with a bar on top, and standard deviation I'm going to write with x with a little subscript x down the bottom there. Okay, this is what we need to know about the normal distribution. A very, very simple rule. It's called the 68, 95, 99.7% rule. Once you know this rule, you are good to go with the next part of the textbook. So, here's the rule. 68% of observations, I should say, in any normal distribution approximately I'm sorry about this. There's a bug with this software where the cursor disappears after a while, and I can't fix that at the moment, so I'm writing blind here. 68% of observations lie within one standard deviation from the mean. And I'm just going to abbreviate this now. 95% within two standard deviations from the mean. Yes. And 99.7% within three standard deviations from the mean. Yes, you can. I will. Yeah, so you can go. Yeah. Okay. All right. So this is the rule.
I have a question.
Yes, Emily.
So, you know how I've done literally no work? What work do you actually want me to do? All of it?
Let's chat about that. Okay, we'll prioritize what's most important. I'm tempted to say all of it, but you know, I'm realistic as well. Because you've got other subjects as well, so I'll give you an order. Okay. Yeah. All right. All right. Have you all got this down?
No.
Well, probably a good idea. It's in your textbook as well, but how many of you actually read the textbook?
I only read that one.
Can I move to the next page?
No, I only just started.
Okay. All right. So, yeah, approximately. Yes. How much longer do you need to write?
I'm writing lines not higher than 95.
Okay. So 30 more seconds?
Hey, Institute, I've done it. I'm up to date.
Okay. Okay, you're almost done. All right, I'll write the rule.
I'm doing the 99.
Okay.
It means from 99.
Yeah, the sentence structure is the same. So you just need 99.7 and 3. So 99.7% within 3 standard deviations. Okay. Let's do an example. So this is quite challenging next year, but this year I think it's quite straightforward. So I need to come up with an example off the top of my head. So height in a class is normally distributed with mean, let's say 160 centimeters, and height, let's say 4 centimeters. Complete the following sentences. Approximately 68% have a height between some number and another number centimeters. 95%, you can see where this is going. Between blank and blank centimeters, and 99.7% have a height between no, I can't get rid of that line. What? All right, this is really glitched out on me. Oh. It's better. Okay, sorry about that. All right, so here's the picture, guys. Yeah, there's a picture. So what we're saying is 68% will lie within 1 standard deviation from the mean.
On the mean bit, what was the mean on that scale?
The dotted line. Okay, so if I go from the mean, the middle, and go outwards 1 standard deviation in both directions, I will occupy 68% of the sample or data. Okay, so in this example, I've told you that the mean, that is the middle, guys, I said the laptops don't need to be open. Why are they out? The mean is 160, and I'm really sorry, this should say standard deviation, not height. Standard deviation. Now this will make more sense. The mean is 160, and the standard deviation is 4. All right, so if you can complete this question, you're good to go with this. This is all we have to do. Okay, so 68%. If I start in the middle, the mean, and go out one standard deviation in both directions. So, does anyone have an idea what numbers I should put in the first sentence?
68% implied between just half 68%.
Nope.
Right.
180 to 170. 140 to 170. 160 and 4.
No.
180.
No, I think you're just calling out random numbers.
68% of the height between 140 and 170. Does that work?
Alright, here's what's happening. We've got a normal curve like this. This is the mean. And this is the standard deviation here. And what we're saying is, if we go out from the mean in both directions by one standard deviation, we get 68% of the data. So let me draw the graph again, this time with 160 in the middle, and the standard deviation is what? What's the standard deviation?
68%.
No, the standard deviation is not 68%.
Oh, so it goes up by 4. Is it 156 to 164 and 156 to 164?
Okay, so, oh, I heard one. Did you say 156 to 164?
No, I said 160 and 4. That's completely different.
So, this.
What's that mean?
Okay. That's alright.
Yeah.
Okay, so it's this one, okay? Alright, so you get your start in the middle and then add and subtract 4, and that's it. Okay?
Then for the next one is just.
Go ahead.
What?
Oh, so would it be double it the next one?
That's it.
So then would we take 8?
Yep.
And then would be 16?
Just add another 4.
12. So we please turn the air conditioner off?
Yes. Thanks, Tyler. Alright, do you want to do one more? Like, have I confused you? Do you know what standard deviation means? I think that might be where we have an issue. So I'll just quickly draw a diagram here. Standard deviation is a measure So I'm going to try to explain standard deviation to you very, very briefly. If I made the standard deviation larger, then the curve would be sort of like this. Like fat. I don't know if fat is the right word, but it would be wider. That is to say, more spread out. Okay. I've actually got some graphs I can show you, so don't worry about this. So I'm going to my Year 12 folder now. And let's see, topic 1. Oh no. Typed notes, here we go. Alright, so you get to see my Year 12 notes. Okay, so on the screen now, I've got 3 graphs with the same mean, but a different standard deviation. So the first graph is in blue, standard deviation is 1. When I go to orange, the standard deviation has gone up to 2. And when I go to green, standard deviation is 3. Can you tell me what happens? It's wider. Yep. If I change the standard deviation, I change how spread out the data is. If I change the mean, I move the center position of the graph. Okay? So you don't really need to know this year, but I understand that every time I say standard deviation, you might not really know what I mean by that. Standard deviation is just a measure of how spread out the data is. Okay? All right, so I'll just ask again, who wants another example with a normal distribution? All right, we'll do one more. All right. So, I won't do study scores because that's on your assignment. I'll pick a different one. IQ is a very old and outdated way of measuring intelligence. So let's go with 99.7% of people have an IQ between blah and blah. All right, suggestions. Let's remind ourselves, what does the 68, 95, 99.7% rule state? It's actually a question on your assignment. I'll give you a mark just for stating the rule. Say it again, Jess. Okay. Standard deviations.
Is that what you wanted us to say?
Yep. Yep. So 15 is the standard deviation, and I'm using 99.7%. So the third one. 15 times 3 is 45. So now I just need to do 100 minus 45 and 100 plus 45 to get me my two numbers. Did I go too fast? AJ? Yes. Yep. What if I changed it to 95%? What would your new answer be? Good. So if it's 95%, Now I have 2 standard deviations instead of 3. Very good. That's right, because 15 times 2 is 30. So 100 minus 30 gives you 70. 100 plus 30 gives you 130. I don't know that people use IQ very much these days. Or the MBTI. But that doesn't assess. MBTI assesses preferences and personality. IQ is measuring a particular aptitude for problem solving and pattern recognition. Yeah. Yeah. I don't know. Bruce?
And then 68% of the A5 and
115. Yeah. Very good.
Right, so